All right, welcome ladies and gentlemen to section 1.8. This is our last lesson from chapter 1. This is going to be dealing with our last types of inequalities. We're going to be looking at polynomials and rational types. Rational just meaning we're looking at fractional functions and determining if they are greater than or equal to 0 sort of thing. All right, so let's take a look first at polynomial inequalities. Something like this, stating that x squared minus 2x minus 3 is less than 0. And I'm going to explain basically what we're going to do, and we're going to explain how to do it both graphically and non-graphically. So, if we were to look at this function right here, this function can be factored. We want to figure out we basically want to figure out how to graph this or where it is actually 0. Oops, not 3x. X minus 3 and x plus 1. That's basically saying the same thing. We're factoring it. We're looking at where it's still less than 0. So if we were to graph this function, we would have x equals negative 1 right there. And we would have x equals positive 3 right here. We'd have 2 of our x-intercepts. And this function does this, and basically looking to see where is that function less than 0. Well, less than 0 means below the x-axis, and greater than 0 would be above the x-axis. Since I want to look for where is it less than 0, I'm looking for where is it below the x-axis, and that's right there. It's below the x-axis between negative 1 and 3. So as an inequality, we would say x is between negative 1 and 3. And that actually is our answer for this particular case. X is between negative 1, x has to be between negative 1 and 3 in order for this statement to be true. So that would be our answer. Now, graphically, it makes sense because most of you can visualize a graph and see where is it above the x-axis and below the x-axis. But there's another way we can do this, and this we call a sign chart. Sign chart is basically just a number line, and we put what we call critical points down on this number line. The critical points are where things are 0. So we know that at negative 1, the function is 0, and at 3, it's also 0. But then we need to know what is happening in each of these intervals. We have the interval down here, we have the interval in the middle, and then we have the interval on the right. So what we just get to do is we get to test a point. Now, I didn't mention this. You don't have to do both of these ways. Choose one or the other. Sign charts are sometimes faster. Remember, we call these critical points. So I just choose a point that's on the left of negative 1. So let's just choose negative 2. If I choose negative 2 and I plug that in, I get positive 4 plus 4 minus 3. So 4 plus 4 is 8 minus 3 is 5, which means this is positive. It's positive 5. That's all I care about. In here, between negative 1 and 3, I choose a number. I'm going to choose the number 0 because it's easiest. 0, 0, and a minus 3, which means it's negative. Likewise, I'm just going to choose an easy number. I don't care what you choose. I'm going to choose 4. 4 squared is 16. Minus 8 is 8. Minus 3 is 5. That gets a positive value. So this tells me, because I'm looking for less than 0, I'm looking for negative. It tells me, again, x has to be between, has to be between negative 1 and 3. So again, my answer to this question is, what x values make this true? Well, the x value is between negative 1 and 3. So this is kind of the explanation of what I just did. Find all the zeros of the polynomial. That was negative 1 and 3. And those zeros are where the polynomial changes sign. You notice when it crosses the x-axis, it goes from being positive to negative or negative to positive. And then we test the intervals created by those zeros. That's what I did on the sign chart. And then we state our answer in interval notation. I didn't do that, sorry. From -1 to 3, oops, yuck, 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 yuck. Don't do that. From -1 to 3, this has the same meaning as -1 to 3 like that. That's interval notation. This is inequality notation. That's interval notation. All right, some more polynomial examples. This one here, x squared minus x minus 6. So like before, I want to figure out where are my critical points. So that's how that one factors. That means on a number line, the only numbers that I care about are -2 and +3. Make sure you put those in the correct order. Just because I put 3 first here doesn't mean it comes first on a number line. Should be kind of obvious. We know that those two numbers make the function 0, so we're just going to tell ourselves that. In the middle here, I'm going to test something in the middle. Well, it just so happens that 0's in the middle, so I'm going to plug in a 0. I get, if I look at the factored form, that's negative times positive, which is going to be negative. By plugging in 0, that becomes -3 and a +2, which means I have a negative and a positive multiplied together to get negative. -2's here, so let's just look at -3 because it's on the left. Negative minus negative, okay, or minus, that's going to be negative. -3 plus 2, that's positive. Or sorry, that's negative. -3 plus 2 is negative. So we get negative times negative is positive. And if I just test a 4 here, 4 minus 3 is 1. 4 plus 2 is 6. Those are both positive, so the product is positive. And I want to know where is the function less than 0. Well, in this case, my answer is from -2 to 3 uninclusive. Well, something like this might be a little bit more challenging, but I don't think it's anything that we can't do. Now, we can only find these inequalities compared to 0, which means I need to add 48 to both sides. Oops, add 48 to both sides. So now it's greater than 0. And I'm pretty sure we can factor by grouping here. So if I take the x squared out of the first two terms here, so I get 2x minus 3. And I take the 16 that's in common out of this, I get 2x minus 3. Well, now this factors to 2x minus 3 times x squared minus 16. Okay, well now I got to do another factoring because x squared minus 16 is x plus 4 and x minus 4. But now that I have it fully factored, I can do my sign chart. In this case, I have 3 critical numbers. I have a -4, a +3/2, and a +4. So I need to test all the points in here, or all the sections. Here, if I plug in a -5, just for the heck of it, oh, by the way, these all make zeros. If I plug in a -5, that becomes -10 minus 3. Okay, so that's negative. -5 and 4 make a negative. -5 and -4 make a negative. Therefore, negative times negative times negative is negative. All right, between -4 and 1.5, there is a 0, so 0 is nice. I can come back up here to the original, plug in 0, 0, 0. I get plus 48. Between 1.5 and 4, there's a 2. 2's kind of nice. 2 times 2 is 4, minus 3 is positive. 2 plus 4 is positive, 2 minus 4 is negative, and positive times negative is negative. And over here on this side, I can plug in a 5 to see what happens. 10 minus 3 is positive, 5 plus 4 is positive, and 5 minus 4 is also positive, therefore that product is positive. And now we want to figure out where is it greater than 0. Well, it's greater than 0 here, and it's greater than 0 here, and therefore we're going to write from -4 up until 3/2 union 4 to infinity, because this section here just keeps going on and on and on, and it's always going to be positive. And we can test any point in here, and it will always be negative between 3/2 and 4. It'll always be positive between -4 and 3/2. That's the whole nice thing about this. Let's look at that one right there. I want to know x squared plus 2x plus 1 is less than or equal to 0. Well, if I factor that, I get x plus 1 and x plus 1. Let me take a moment here. What if the thing does not factor? How are you going to figure it out? Well, if it doesn't factor, you have to use quadratic formula and then get some decimal approximations to solve for that. Okay, x plus 1, so that means my only critical point is at -1, and that makes it a 0. And in this particular case, if I plug in a -2, I get a negative and a negative, which makes it positive. And on the right-hand side, if I plug in a +2 or a 0, I guess, I get plus plus, which makes it also a positive. So the question here is, where is this function less than 0? Well, it's never less than 0. But where is the function equal to 0? Because it's less than or equal to 0. Well, it's only equal to 0 at -1. So we would do a little squiggle box or squiggle bracket, and we'd say our answer is -1, and that's it. Or x equals -1. All right, let's go ahead and move forward into the rational inequalities. Rational inequalities are a little bit more challenging because you have to take this and you have to subtract 3. So you have to do a lot of extra math here, but that's the only way it's going to work. So if I subtract 3, I need common denominators. And the nice thing is it's going to work exactly like the other problems. It's just a little extra steps that you have to do. So this becomes a 3x minus 15, but it's being subtracted, by the way. So I get 2x minus 3x, so I get a negative x, and minus 7 minus -15, so that's a positive 8, because it's minus a negative 15, over x minus 5 is less than or equal to 0. Oops, wrong direction there. It's okay, we'll do it somewhere else. We'll do it right up here. Okay, now, critical points. You'll see this in a second. Critical points are whatever makes the numerator 0 and whatever makes the denominator 0. So there's two values here. If x is 8, it makes the numerator 0. And if x is if x is 5, it makes the denominator 0. So we have a 5 and we have an 8. So let's think about, when I plug in a 5, that's undefined, and when I plug in an 8, it's 0. Undefined because the denominator can't be 0. So let's see what happens when I plug in a negative, not negative, let's plug in 0, because that's the left of 5. If I plug in 0 here, I get positive 8 over negative 5, so that's negative. If I plug in a 6 right here, negative 6 plus 8, well, that's positive. 6 minus 5, well, that's positive, so that's positive. And if I plug in a 9, negative 9 plus 8 is negative. 9 minus 5 is positive, so therefore it's negative right there. And we want to know where is it less than or equal to 0. All right, so it's less than 0 over here. So we're going to start at negative infinity, go all the way up until 5. Use parentheses because I can't let it equal 5 because that's an undefined term. And, or union, oops, we're going to use 8 because it's less than or equal to, going until infinity. And that is going to be our answer. So this is what we did. We combined the fractions together, make it one fraction. I didn't write that, but it's got to be one fraction with the inequality compared to 0. Then you find your critical points. Critical points are zeros of the numerator and zeros for the denominator. And then you're going to test a point in each interval. So we could do something like this. In this numerator here, we get x squared plus x minus 6. Well, that's going to be x minus plus 3 and x minus 2 all over x greater than or equal to 0. And then our critical points are going to be negative 3, 0, and 2. 2 makes that 0, negative 3 makes that 0, and 0 makes that 0. And then we just get to plug in some points. If I plug in negative 4, I get negative, negative over negative, which means it's negative. Negative 3 makes it a 0. I plug in, actually if that's negative 4, let's plug in a negative 1. Negative 1 makes positive, negative, negative, so that's positive. 0 is undefined. If I plug in a positive 1, that makes positive, negative over positive, so the whole answer is negative. And if I plug in a 3, I get positive, 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 so the whole thing is positive. And if I want to find where is it less than or equal to 0, or sorry, greater than or equal to 0, we just use these things. So from negative 3 inclusive to 0, it's positive. And from 2 to infinity, it's also positive. All right, the last thing here is domains, but it actually follows along with the last piece. For the square root functions, everything under the radical must be greater than or equal to 0. So you have to say 64 minus x squared is greater than or equal to 0. Well, that follows exactly the same rules as before, or sorry, minus 4x squared. And in this case, x over x squared minus 9 has to be greater than or equal to 0. And that's really the same process as before. You just use your sign chart, or factor this one to use your sign chart. And that's about it. So I'm going to leave you guys with that. Here's your assignment. I hope you guys have a good evening. I will see you guys tomorrow.